Okay guys, in this video I'm going to be showing you how to create the offset crank. Right here I have this offset crank already done, so that way we can see what it looks like compared to the actual drawing that I have given you. We see from the front view that it looks like a rectangle with a bunch of cutouts, and we see from the side view that it is a cylindrical object with some cutouts in it. So let's go ahead and get started. We are going to start on the XY plane. Make sure that when you are doing this that you are using your origins and your planes correctly. I made a rectangle and I'm now going to connect the center point to the origin. From here I'm now going to dimension this. This has the total length of 4 inches. And the total height of 2 inches, which in this case, since we are going to be revolving it, we're just going to revolve it 1 inch, or use 1 inch and then revolve it to create 2 inches. So go ahead and revolve it, and we're going to select this bottom axis, or this line right here of the rectangle, as our center axis. Go ahead and say OK. And here's where we're going to get started. I'm going to flip this around and look at the left side. I'm going to create a sketch here, and all I'm going to do is project my geometry, and I'm going to draw 2 lines like this and a line straight across. And I'm going to make sure that these lines are equal with each other and that they line up. I'm going to use my vertical constraint, and that this end point here lines up with the midpoint of my line, and then I'm going to connect that midpoint to the origin. Now that I have that, I'm going to connect, using my coincident constraint, this end point to the circle and this end point to the circle. Okay, so now I have this, and then I'm going to go ahead and draw a circle right here. This circle has a diameter of 0.21 and is vertically located 0.63 above the origin. Once you have that, rotate it like this and extrude. We're going to select this corner, or this segment of our circle, this segment of our circle, and that center circle that we created. I'm cutting this out 1.5 inches. If we look at this from the front, if we look at this from the left, it looks very similar to our drawing that we were originally given. I now am going to create a new sketch on my XY plane. Once you're on the XY plane, right click and scroll down to Slice Graphics. From here, I can now go ahead and add different rectangles that are going to be my cutouts. I'm going to add a rectangle here, a rectangle here, a rectangle in this corner, a rectangle here, and a circle right about this area right there. Now all of these are floating, they're not connected to anything, so now I can go ahead and start dimensioning it. But before I can dimension it, make sure that we project our geometry. We want to project this line of our this left line of our main object and this right line of our main object, and we're going to use that to dimension off of. So the height, or the distance that this rectangle extends into the part, is going to be 0.375, and the width, or the horizontal distance that this extends into the part, is 0.5. This has a width of 0.75 and is 0.75 away from our left face. and extends into the part well, it's measured differently than what we're used to, so I'm just going to click on this bottom face, or that bottom line, and then this bottom corner down here, and this should be 1.375. Okay, now I'm going to go ahead and move over here. This rectangle is located 3.125 inches away from the left face and is 1.88 inches away from the bottom. And this has a height of 0.25, and from here to the origin, that should be 0.125. It also extends into our object 0.75. And now we can go ahead and dimension this circle. This circle has a diameter of 0.21 and is located horizontally 2.25 and vertically 0.5. Okay, so I know that we have a bunch of these shapes hanging off out of the part, and that's fine. The only thing that I'm really worried about is that is what is actually inside this part. So let's go ahead and finish the sketch, and we're going to extrude. We're going to select this rectangle, make sure that you're selecting the entire rectangle, and then I have to find this circle right here in the middle. Now I'm going to switch it over. The direction of it is going to be symmetric through all, and make sure that you are cutting it. And when we look at it from the side, we'll see that everything will get cut, and this is what we want. We're now going to add a feature right here. So we're going to go to Hole, and I'm going to select this surface right here, and then select this arc as my concentric reference, so that way it moves my hole right on top of that center point. And this is going to be a counter bore that has a hole or a diameter of 1.25, a seat of 1, and and our termination is going to go through all, so make sure that you reselect, or that you go through all, and so that way it changes that. And our bottom diameter is going to be 0.5. Okay, so if we zoom out, this is what you guys should see pop up and say okay. All right, so if we look at it this way, we see that we have a large hole with a smaller hole down the center, and we have a few more extrusions to make. So I am now going to create a sketch on the XZ plane. Pay attention to how it rotates, and then make sure that you rotate it so that way it looks like this, and so that the top of the view cube says top correctly. I'm going to right click and go to Slice Graphics so I can see the inside of my object, and I'm just going to place 2 rectangles like so. I'm then going to make sure that these rectangles midpoints, this midpoint of our top rectangle lines up with the midpoint of our bottom rectangle, and then I'm going to select the equal sign and make sure that both of my rectangles are equal to each other. Okay, now we can go ahead and add dimensions. Our width of our rectangles is 50, and they are 2 inches away from our left face, so go ahead and put that in, 2 inches. And then from this center point to this center point, this should be 0.63. And from this line to the center point, this is 0.63. Okay, so I know that it looks a little silly, but that's okay. I'm just going to grab the edges of my rectangles and extend them out past our object. Finish my sketch, go to extrude, make sure that you select this rectangle and this rectangle, change it to through all for our distance, and cut. Once you have that, you should see something that looks like this. Okay? The last thing that we need to add is going to be a hole on this bottom face down here. The problem with adding a hole down here is that we don't have a flat surface to use. We can't make a sketch on a curved surface, so we're going to have to create a plane to put that on. Okay, so I'm going to go to the pull down menu on work plane and choose tangent to surface, parallel to plane. So I'm going to be tangent to our cylindrical surface and parallel to this rectangle here. Once you have that, a flat plane appears, and I'm going to create a sketch right here. All I'm going to do is now place a point, and you can see it right there. Let me zoom in. Here's my point, and I'm going to dimension this point to be in the proper location. This has a horizontal distance of 1.125. Oops. 1.125. And it is right in line with our origin. That's what we want. Okay. And I'm just going to rotate it like this so we can see. I'm going to click on hole, and it automatically sees that that point is there, and that's Inventor knowing that that's where we want to put our hole. And it's just a regular hole, no seat, and it has a distance, and this hole is just going to go to the center, so I'm just going to leave it at 1 because remember the overall diameter was 2, and the diameter for this hole is 0.21. Okay, actually let me double click on that and show you what that would look like from this edge. Okay, so it goes from the edge all the way to the center. Alright, so now I'm just going to right click on this work plane and go to visibility, turn it off. And one of the cool things that we can do is we can change the visual style. If you go to the view tab up at the top and change or select visual style and go down to wireframe with hidden edges, and we look at it, and we look at this from the right side, or I'm sorry, the front side view, you'll see that it matches perfectly with our original drawing. If you turn it to the left side view, you'll see that it also matches perfectly to our left side view of our original drawing. The next step to this is to put it on a title block, and what makes this a little bit different is that there are 3 section views taking place through this part, A, B, and C. So how do we add section views? So I'm going to change the size of my sheet to a B size sheet, actually a C size sheet, so that way it's a lot larger. And then I'm going to use my O crank, or bring that in, and just bring it in at a 1:1 scale. So now that I have my 1:1 scale O crank brought in, I'm going to go ahead and click on section. Inventor then wants to know which view we need to be sectioning, so we're just going to click on this front view of our part, and then I'm going to hover over this hole right here, and I'm going to click outside away from the center point of this hole, so somewhere down here, and I'm going to draw a line straight up. I'm not going to end it right here. I'm not going to end it right here. I'm actually going to end it above where everything is. I'm then going to right click and say continue, and what you see is that we have our A section happening right here, and we can go ahead and put that in. Okay, now I'm going to do the next section, which is taking place on this view. I'm going to hover over the center of this circle, move my mouse straight down, and I want to make sure that I'm not that Inventor is not clicking over to something different, and that's why it's important to zoom in as close as you can. And I'm going to move my mouse straight up and click, right click, continue, and then my B section will go right here. And then last, my C section will go again on this view. I'm going to hover on this line, move straight down from that line, and then put that section right here, right click, continue, and then my C will go right here. Once you have all three of those section views done, you can highlight all three of these, and I want to move them out of the way, but you see nothing will happen, so I'm going to have to break my alignment. So I'm going to click on section A, break alignment, and now I can move it down out of the way. Same thing with section B, break alignment, and then I'm just going to move my main drawing to right about there, because I do need to put in my original drawing, which was this front view and my left side view. Okay, so here is what you hopefully remember from reading in the book. What is the main, or why are section views used over regular multi-views? Is because look, all of the hidden lines that are happening here, and on the section views you see just the features that you want to see. On A, yes, you can see it here, but it has all this other stuff happening. On B, you can see it here, and on C, you can also see it here. Section views are just a way to help someone better visualize what is happening in each drawing. What I would suggest before you move on is let's increase the scale, probably to a 2:1, and everything should increase. Okay, and this again will help you guys visualize everything. It is now your responsibility to go ahead and finish dimensioning this drawing. Make sure that you have all of the required dimensions. Count however many dimensions are in the original drawing, and then make sure that you have those same dimensions in this drawing before you submit, and then submit it. If you guys have any questions, please let me know, and I'll see you guys in the next video.